Hi guys, today we're going to be going over shapes of molecules. So first I'm going to give you a basic summary of what we're going to be covering today. So this topic is divided into two parts. The first one is going to be molecules with no lone pairs, and the next one is going to be molecules with lone pairs. So an example of a molecule with no lone pair is going to be carbon dioxide. So in this case we have one carbon, which is going to be our central atom, that's going to be surrounded by two oxygens. Alright, so in this case, 4 electrons of carbon are going to be involved in bonding. And I've marked those with a dot. So in this case, since carbon is in group 4, it's going to have 4 valence electrons. And all of them are going to be used in bonding. So in this case, it has no lone pairs. Now let's look at a molecule that has lone pairs. So in this case, we're going to have ammonia. Now ammonia over here is going to have one lone pair. So since ammonia is in group 5 and only 3 electrons are going to be used in bonding, these 2 electrons are going to be called lone pairs. And these lone pairs are going to affect the angle that's going to be there between the nitrogens and the hydrogens. We're going to discuss this in detail in the next video. But first I'm going to go over the number of bonding pairs and the different shapes. So if you have 2 bonding pairs, the shape is going to be linear and the angle is going to be 180 degrees. If there's 3 bonding pairs, the shape is going to be trigonal planar and the angle is going to be 120 degrees. If you have 4 bonding pairs, the shape is going to be tetrahedral and the angle is going to be 109.5 degrees. If you have 5 bonding pairs, the shape is going to be trigonal bipyramidal and the angles are going to be 90 degrees and 120 degrees in their respective planes, and we're going to discuss this also later on. If you have 6 bonding pairs, the shape is going to be octahedral and the angles are going to be 90 degrees and 180 degrees. Now for the next part in this section, molecules with lone pairs, we're going to be discussing 2 things that are in our syllabus. So there's going to be a molecule in which there are 2 bonding pairs and 2 lone pairs. So this is going to be bent and the angle is going to be roughly 105.5 degrees. There's no exact value for this. For molecules with lone pairs over here, if you have 3 bonding pairs and 1 lone pair, it's going to be classified as trigonal pyramidal and the angle is going to be approximately 107.5 degrees. The first type of shape that we're going to be talking about is going to be linear. So in this case, as we talked about previously, the bond angle for linear shapes is going to be 180 degrees. So whenever you're trying to determine the bond angle for any shape, the first thing that you're going to do is you're going to make a simple dot and cross diagram. And if you're confused about dot and cross diagrams, there's a video up on that as well, so you can go check that out. So in this case, for BeCl2, the central atom is going to be beryllium. And then you're going to have 2 chlorine atoms. So in this case, since beryllium is in group 2, it's going to have 2 electrons in its valence shell, and there's going to be no lone pairs in this case, and it's only going to have bonded pairs. So over here, the bond angle is going to be 180 degrees. And over here you have the model for it. So you can see that this is a completely flat structure. So this is completely planar, it's a completely flat structure, so there's going to be no 3D bond notations for this. The next example that we have over here is carbon dioxide. So over here you're going to have carbon as the central atom and you're going to have 2 oxygens double bonded. So in this case, if you have a double bond or a triple bond, you're going to count it as one region of electron density. So in this case, since carbon is in group 4, it has 4 valence electrons. And all 4 of them are going to be used in bonding, so it's going to have no lone pairs. And if you look at it, there's going to be 2 different regions of electron density, so this is also going to be linear. Another example that we're going to look at is going to be C2H2. So in this case, we can look at either of these carbons as the central atoms. We can look at the pink one and we can look at the blue one. And in this case, in both cases, the angle that you're going to get is going to be 180 degrees. So over here is going to be 180 degrees. And if you look at it from this point, it's also going to be 180 degrees. And one other thing to note over here is that all diatomic molecules are going to be linear. So in this case, if you have nitrogen gas, this is going to be 180 degrees. So this is going to be linear. If you have HCl, this is also going to be 180 degrees, so it's going to be linear. The next type of shape that we're going to be looking at is trigonal planar, and the angle for this is 120 degrees. So like we did before, the first thing that we're going to be doing is we're going to be making the dot and cross diagram for boron trichloride. So in this case, the dots represent the electrons of boron and the crosses represent the electrons of chlorine. So since boron is in group 3, it has 3 valence electrons, and in this case there's going to be no lone pairs. So the central atom, the one that I've highlighted in pink right now, boron, has 3 regions of electron density and no lone pairs. So because of that, this corresponds to an angle of 120 degrees and a shape of trigonal planar. So in this case, all these 3 regions of electron density are going to repel each other equally, and you're going to get a flat 2D structure. So this is going to be completely flat and not 3D. The next shape that we're going to be looking at is going to be tetrahedral. So this is going to be a 3D structure. Now if we make the dot and cross diagram for methane, this is what we get. So since carbon is in group 4, it has 4 valence electrons. And in this case, the dots represent the electrons of carbon and the crosses represent the electrons of hydrogen. So over here, as you can see, this is going to be a 3D structure. And the central atom, the one that I'm highlighting in pink, carbon, has 4 regions of electron density, since there's 4 different hydrogens attached to it and there's no lone pairs. These 4 regions are going to repel each other equally. So over here, if you had to draw the 3D bond notation for this, so you would have one carbon, and there would be a straight line going up and a straight line going in this direction, because as you can see, this and this are in the same plane. So these are going to be lying completely flat. But over here, if you can look at this one, the one that I'm highlighting right now in blue, this is coming completely towards. So because of that, you're going to make a wedge. And since this is going away from the camera, you're going to make a dotted bond. So this is normally how you make tetrahedral structures, like the 3D bonding of tetrahedral structures. So 2 adjacent bonds are going to be straight, and the remaining 2 are going to be a wedge and a dotted bond. Another example that we can have for trigonal planar is going to be C2H4, which is ethene. So in this case, we can look at 2 central carbons, the blue one and the pink one. We can take both of these as the central carbons. So if we take the blue one, then it's going to have 3 regions of electron density around it. So the angle is going to be 120 degrees. And if we take the pink one, it's going to be the same thing. So there's going to be one region here, and one region towards this side, since double bond is counted as one region. So over here also the angle will be 120 degrees. The last 2 shapes that we're going to be talking about are trigonal bipyramidal and octahedral. So for trigonal bipyramidal, the example that we're going to be looking at is PCl5. So again, the first thing that we're going to do is we're going to draw a dot and cross diagram. So in this case, as you can see, there's going to be 5 regions of electron density over here. And this corresponds to an angle of 120 degrees and an angle of 90 degrees. So in this case, over here, what we're going to have is the horizontal plane. So if you look at it from this point of view, this is phosphorus, and these are the chlorines that I'm marking right now. So if you look at the bonds that I'm highlighting right now, over here, the angle is going to be 120 degrees, 120 degrees, and 120 degrees over here. Now if you're going to look at the vertical plane, in this case, so this is going to be the phosphorus over here, and the white circles are the chlorines. So if you look at it over here, this angle is 90 degrees, and this angle is also going to be 90 degrees, and this will be 90 degrees, and this will also be 90 degrees. So in this case, for trigonal bipyramidal, you have two angles. There's 120 degrees and there's going to be 90 degrees. So in the vertical plane, your angle is going to be 90 degrees between the vertical and the horizontal, and in the horizontal plane, it's going to be 120 degrees. So if you had to make the 3D bond notation for this, you're going to make 3 chlorines that are going to be in the same plane, and one of them is going to be coming out straight at you, like this one. So you're going to make a wedge for that. And one of them is going to be going away from. So over here, if you look at the chlorine that's going away, in this picture, the one on the horizontal plane, this is going completely away from the camera. So for that, we're going to be making a wedge. And this is the 3D bond notation for trigonal bipyramidal. So the last shape that we're going to be looking at in the category of bond angles with molecules that don't have any lone pairs is going to be octahedral. The example that we're going to be looking at is going to be SF6. So in this case, we're going to have sulfur and it's going to be surrounded by 6 chlorines. So in this case, the angle over here is going to be 90 if you look at it from this point of view. So this angle is going to be 90 degrees. This angle is also going to be 90 degrees. This angle will be 90 degrees. And this angle will be 90 degrees over here. So between the vertical and the horizontal plane, so this is the vertical plane, and this is the horizontal plane over here. So the angles between these are going to be 90 degrees. And if you look at it in the vertical plane over here, the one that I marked in pink, this is going to be 180 degrees. The two angles that you have in this case are going to be 90 and 180 degrees. So over here, if you look at it from this point of view, this lies in completely one plane, right? So if you had to make the 3D bond notation for this, you would make phosphorus, 1 chlorine above it, and 1 chlorine above it. Now if you look at what I've marked from the pink highlighter, these bonds are coming directly at you. So for that, we're going to be making a wedge. And these bonds over here are going directly away from you. So for that, we're going to be making dotted bonds. So this is the 3D bond notation for octahedral.